Welcome, everybody, to an exciting Wednesday of Dev Summit. My name is David Vitale. These are my co-workers, Andrew and Youngyao. We are members of the ArcGIS API for Python team. We're going to be doing a session today of mapping, visualization, and analysis. We're going to talk, each of us, for around 15 minutes, and then we'll yield the floor for questions. So we hope you enjoy it. Let us know if you can't read anything. Feel free just to yell out if our fonts are too small. But also, when our talk is done, if you like our talk, please leave us a 5-star review. If you don't like our talk, please do not leave us a review. So the ArcGIS API for Python, I'm just going to do a brief introduction for any of you who have never heard of this before. The ArcGIS API for Python is Python for your web GIS. It is useful for a lot of different roles. A lot of different types of people use the Python API. Administrators and DevOps people use the Python API to manage users, groups, and content. You can update web maps. You can automatically from code add users, update groups. It's also used by analysts for a lot of spatial analysis, imagery, location analytics, making of web maps and web scenes, visualizing data, which is kind of what we're going to focus on in this session. It's also useful for content publishers. So if you have a lot of files, a lot of SD files on a drive somewhere, you can upload all of them in batch to your portal or to ArcGIS Online. So again, it's just Python for your web GIS. So when you're getting started with the Python API, the core entry point, it all starts with your GIS. So from arcgis.gis import, uppercase GIS is the import statement. GIS is a class where you specify your portal name or your ArcGIS Online organization, your username and password, and then once you're there, you're ready to go start using it. You can search for different content just like you would in your portal, from a web browser. Instead of importing it there, you just do gis.content.search. You get a list of all the items, and you can display all the items inside of a Jupyter notebook, which I'll show you in a bit. You can also publish local files. So if you have SD files, CSVs, shapefiles, you can publish all of them to your portal. Inside of a Jupyter notebook environment, you can also visualize layers on a map. So we have this map widget class, which is a JavaScript map in front of you that you can control from Python, add some layers, do some spatial analysis that way. From a bit more technical standpoint, this is just a general overview of the Python API. So I showed you the GIS module for your entry point connecting to it. There's also a geoanalytics model. If you have an enterprise deployment with geoanalytics, you can interface with that. Geoprocessing, geocoding, geoenrichment, those use your portal's respective services for that. Python API calls into them via the REST API. There's widgets, there's network analysis, mapping for web maps and web scenes, raster. So we do try to cover as much as possible from the Python API. And that's that. So I could keep on just showing you PowerPoint slides, but I think you all like code a lot better. So we're gonna, show you some cool things. The first thing I'm just gonna show you is just in general the Jupyter notebook environment. So I don't know if any of you saw the plenary or have been listening to this Dev Summit, but I'm showing you right now the hosted notebooks platform inside of ArcGIS Enterprise 10.7. This is the viewing of Jupyter notebooks as portal items inside of your portal. So inside of this portal, as you can see, I have my normal tabs as before. There's also this new notebook tab. So you can create a Jupyter notebook item and share it with other people, and you know that you'll be running on the exact same runtime. So I'll just be using it for the purpose of this demo because it's easier to manage than having all my files locally and having to make sure I have the exact right Python module versions. But this is the Jupyter notebook environment. How many of you here have used Jupyter notebooks before, by a show of hands? Cool. That's a lot of people, so I won't go through the specifics of that, but I'm going to just create a GIS object. I'm just going to make an anonymous ArcGIS Online connection. And when I call gis.map on the USA, I have now made a new map. This is a interactive JavaScript widget. You can rotate it. pan and zoom, very responsive, very, very easy to use, pretty intuitive. So I just made a map and I've saved it to this variable map1. So I'm now going to look for an item. In this case, I'm just doing a search of USA freeway system owned by user Esri, so an official Esri item, only looking for item type feature layer. So this can be kind of good to query your, when you're doing your analysis, looking for the exact same thing so you don't end up with somebody else's item. But so I have now this list of only one item that turned away, the USA freeway system. So I'm going to index into that list, get the first item, and then the map widget item. So we have that again, remember in this map1 variable. I'm going to add that to the map. So I pressed add layer, that cell is run, and as you can see, I have a lovely map of the USA freeway system. Pop-ups are there just as you would expect in Map Viewer. Yeah, so this is good, but this we haven't done much more than you can just do by looking at this in Map Viewer, right? So why am I in a Jupyter notebook? Well, what you can do is from Python, you can really kind of gain a deep insight into the items that are on your map. The Jupyter Notebook environment is really very great for exploratory analysis. So I have this freeway item, I see it on a map, but I want to know more about it. So what I can do is I can look through all the layers on it. I can print out from code the URL and the field names of this. So if I run this, you'll see that I have the actual service name of the underlying feature that is running, and then I also have the different field names on it. So it looks like object ID, route number, class, all this stuff. So this distance in miles is how long the road is. So I'm from Chicago, and there's US Highway 90, and 90 even reaches all the way out here to the West Coast. So that's a very, very long highway, right? But then here in Southern California, you have some of the smaller highways that don't, go all the way to the rest of the country. So we're going to gain an insight into this dist miles field right here. So I'm going to define a custom renderer. Andrew's going to go more into a deep dive about renderers, but I'm just going to define a class size renderer. And what I'm going to do is I'm going to add that same layer again, but this time I'm going to tell from Python, hey, I want to use the class size renderer, and I want this to render with this distance of miles field. So I'm going to run this, and when I scroll back up, you can see that my map has changed. These lines have gotten a lot thicker. Now it looks like they're all thicker, so it doesn't seem to be that useful. But if I do run these two lines of code right here, which is changing the center and the zoom of my map, so from code, instead of panning and zooming, I can say I want to be at this lat, this long, and I want to be this zoomed in. I get to look at a lovely map of the LA area of Southern California, and you can see that some of these smaller highways are actually thinner than the other ones. So this is the 10, I believe, right here. No, this is the 10 right here. And since that's a very long highway, it's very thick, right? But then out here I should have looked at these roads before. I think this is a smaller road. So you can see that the distance of the whole thing is a lot smaller, so it's thinner. So you can specify some custom rendering options on that to kind of gain a good visualization of your layer, and you can control all of this from code in a very sort of exploratory analysis way. So that's one map. I'm going to make now another map of good old Seattle, Washington. And I'm going to add a polygon layer this time. So just like how I used the size renderer before, I'm going to use now the classed color renderer. And this is census data. I'm only going to look at the state of Washington because I only care about that. I'm going to use the class color renderer, the population field, and with an opacity or a transparency of 0.07 of that feature layer. And then when you draw it, you can gain an insight into different population densities of the state of Washington. So you see the Seattle area, this county is a lot darker red than out here in the Spokane area, or down here in I've never been to that part of Washington State, but you can tell that this part is less populated than mostly the Seattle area. So just another type of renderer for polygon data to gain some more insight into a feature you're looking at. One more map in this notebook. We're going to go back to LA. I'm going to do point data on a map, but this time I'm going to specify that this is a heat map renderer. So as you can see, it just from a few lines of code, it's already able to do that type of rendering, to go from the point data to aggregating all of it to make it look like a nice heat map that you can see a little bit of light orange over here, and then the heavy concentration obviously over there, some other light orange. So just a way that you can use the Python API and Jupyter notebooks to sort of create a map inside of a notebook, look up items associated with your portal, display them, and then not display them just in the default way, kind of look at those items, gain some info into that, and then create rendering on the fly for this. So that's one notebook. I've got a few I'm going to show you, and then I'll pass it over to my colleagues. Let me just let this load. I'm going to show you, so one thing that you might have noticed if you have a keen eye is this lovely icon in the upper right-hand corner of all of the maps. This is, when you click on this icon, you actually are able to, transported to me, you're able to view a 3D version of the map. So you can go just in one button click from 2D to 3D analysis, which is pretty neat. I'll go more into that in this notebook, but you even get the same data that you saw before, and if you can add elevation layers to sort of gain some cool insights into some other types of situations. Give this a sec to load. Actually, while it's loading, I'll load my other notebook to save some time. So again, here's just another way of gaining access to the 3D map. You can press that button. You can gain insight programmatically in the map widget so right now I'm in 3D mode. My zoom is at 3. My tilt and heading are at this. I'm going to zoom in to Chicago, give it a bit of a tilt and a bit of a that. And then if I rerun this cell, you see that my values have been updated. So you do get two-way, connection from code of what you're panning and zooming, and then also what you see from a code standpoint. Yeah, so that's that. That's 3D. I'll get to a cool example on that, but I'm going to talk now about callbacks. So every single thing that you've seen before now has been me running Python code, and that Python code is running. When I say print map info, this code, all this thing happens right here when I press run on that cell. Callbacks are a cool way to have a sort of asynchronous workflow towards the type of code that you want to run. So in this code cell, I have made a map, and I've just defined a function called find address, and I have registered this to be on click. So this method right here hasn't actually done anything. It's just been called, it's just been defined, it hasn't actually ran. When I specify this on click, I pass it that function name, which allows me to, when I click anywhere on the map, like right here, you see down here this Petco Park was printed out. So what's happening behind the scenes here is when I click on this map, this function find address is called, and the geometry is passed in as this parameter, so right here. So I'm able to draw a single point, you can see that point right there. But that point has geometry, it's of that type, and I can do a reverse geocode of that point and look up the actual information. So here we're in San Diego, and when I press here, it is able to actually print out Petco Park. If I press here, it's able to print out the exact location of this. Here it would print out the address of this. So just a cool way of, instead of you running each bit of Python code, instead of you pressing Shift-Enter to run it, you say, hey, I'm going to define this function for you. Don't actually call me yet, but then when I click on the map, I want you to run. So back to 3D, I'm going to show you one of my favorite places in the world, which is Zion National Park. I find this really cool that you can have this level of elevation. So this is a hike up in Zion called Angel's Landing. If my mother asks, I haven't done it because it's a very, very tall hike that seems dangerous, but it's not. But what's cool is I can pan and zoom and sort of gain access to all these canyons, and I can add the layer of the trail, and you can see, so you start out on the Angel's Landing hike down here on the ground. It's pretty flat in the beginning. Then you hit these heavy switchbacks, sort of go up the canyon through here. Let me pan and zoom around. And then this is the treacherous part that my mother does not need to know I did, which was you're on this sort of ridge going all the way up to the top. And then once you are up on the top, you gain a great insight into the valley, just like this, like that. So I found it very cool that I did this hike in person, and then this was pretty much the exact view that I saw. So just that's another way that you can visualize some of your spatial data. You can also add a custom renderer on this. So if I scroll back up, you see that the lines are a little bit easier to look at now. It's sort of in a 3D type of mode. And when you're done, just like in all of this type of stuff, you can save what you did as my Zion Park web scene, which is now persisted in my portal. So I can now share this with anyone else. So the workflows that you do in Python and Jupyter, adding layers to web maps, viewing inside of the widget, everything you do, you can always save and persist across the ArcGIS platform, which I believe Andrew is going to talk more about a little bit. Yep. So I'll actually pass it over to him now.
All right. Well, thanks, Dave. That was really cool.
You got to.
Yep, we're going to switch over. We're going to see some cute little pandas. And we're going to talk about pandas and how you can use the spatially enabled data frame to enhance your workflows. And this is something that comes with the Python API for ArcGIS. So how many of you are familiar with pandas? Can I just see a show of hands, please? That's a pretty good amount of you. And I'm sure you would agree with this, that it kind of makes your data very tactile and you're able to work with it very easily. So what we did is we took the concept of of pandas data frames and we extended it. We added in namespaces. So what we did is that we left pandas as it is and we used their extension framework and we created 2 custom namespaces. The first one's called geom, and that exists on a geometry series. The next one we did it on the data frame itself, and it's called spatial. And this allows you, if you were to think about it, to act on the data set as a whole. So spatial acts on the data set as a whole, so you can do things like reproject. And geom operates operations that exist exactly on each row's geometry. And what we were able to do is we were able to take data and make it very tactile. So feature classes can be very rigid. You have to access cursors and you have to do everything. And when you make an insert, it happens, or an update, it happens. And in this is all happening in memory. So you can experiment with your data, mess around with it, and if you don't save it and you just delete it out of memory, it goes away and you can start over again. So that's what's really cool. But it's also cross-platform. So if you're working on a Mac or you have Linux or Windows, you can do all this itself. It works with the Esri ArcPy geometry engine, and it also works with Shapely and Geos. So if you might not be using ArcPy, and let's say you're on a Mac, you could use Shapely to do your geometry operations. So it's really cool. For reading and writing data, we leverage Fiona, PyShape or Shapefile, and ArcPy. So you have a lot of options of how you can work with your data. It all starts with an import, just like we did with the ArcGIS GIS object. So first you import pandas, so import pandas as PD, and then you do from ArcGIS.features, import GeoAccessor and GeoSeriesAccessor. And that loads those namespaces into memory. And you can go ahead and start consuming data now. And you can consume data many different ways. You can consume it directly, so you can pass in a feature layer like we did here to create SDF1. You can consume local feature classes. So if you have local data on your machine, you can consume it. So here's an example of consuming a shapefile. Or you can do something that I think is really neat, is you can convert data that isn't natively spatial and make it spatial. So if you can consume, here's the USGS government earthquake feed, and it has a latitude and longitude columns. You pass that in and the projection you want it in, and it'll produce a spatially enabled data frame for you. You can then turn around and persist this. So from your GIS object, you can do gis.content.import data and save it off to a hosted feature service layer, or you can even persist it locally. So you can take your spatially enabled data frame, do your dataset operation, and say to feature class and write it to disk. So I'm going to go ahead and talk about mapping now. So now that we've loaded data in, how can we visualize it? Well, I'm going to connect to my GIS using profiles. So just like most things from ArcGIS, that import GIS and create a GIS object. I'm going to create my first map. So we have an area over the New Jersey metro area, and we can add data to it. And it's as simple as doing df.spatial.plot and then telling where you want to put the information. And we took a blank map and we added an in-memory data set to our layer. So this doesn't exist anywhere on server. This is all happening locally. Now we can go on and do more advanced rendering techniques like we see here. So we're taking that same city data set that we used before, and we're going to plot it, and we're going to use a more advanced simple renderer. So I'm going to tell it simple, and I'm going to tell it the style I want. So I want diamonds instead of circles. I want to use a color scheme called red, and I want to use these color schemes map to matplotlib's color ramps, and you can tell exactly where on the color ramp you want your colors to come from. So in this case, I'm going to take the 10th one. And then I want the outline colors to be blue, and I can also state my size. And you can quickly generate visualizations. You can also do class break renders. So here's taking those cities, and we're classifying by state. We're going to use a unique renderer, give it a column, and I wanted to let the spatially enabled data frame to pick our color scheme for me. So here it uses jet by default. So here it's just rendering and it's picking the colors as they come along for each value in the column and generating that renderer for us. You can do class break rendering as well. In this case, we're going to look at population. And it supports the methods that Dave showed with the various classification algorithms. So you can do natural breaks, equal intervals, things like that. It supports all that information. But what's pretty neat is that we also can pop up a legend. And this information will show us actually where our class breaks are in this instance, and based on our number of class counts for our point data set. But it's not all about just rendering information that's points that I showed you here. You can do it with any geometry type. So here's an example with polygons. I just took in a random feature layer from the census, so these are block groups, and I queried out information just for the state of Washington, and I put it on a map. So I'm doing this all in memory. So I want to do class breaks, and I picked a method, a field, and the color ramp, and the number of counts, and I have my information on there. I could then turn around and save this out, and the data would persist, or I could even take my individual spatially enabled data frame and save that as a hosted feature layer or a feature class as well. Now, I've alluded to the color maps and how they map to matplotlib, but if you're like me, I'm a pretty visual person, and I want to know what color maps I want to pick. So we developed helper functions in the ArcGIS.mapping. You can display all the color maps, and you can scroll through each one and pick the one you want instead of just randomly choosing color maps. Or you can even specify RGB and A values itself. So that's some things that you can do with rendering. Next, I want to talk about spatial indexing and using spatial indexes. And the benefit of using spatial indexes in spatially enabled data frame, it allows you to quickly find spatial locations, just like you would in a feature class, but they're on demand. And the default spatial index that's created is a quad tree index. And the reason we chose quad tree over anything else is because it can be built really fast. And if you were to visualize a spatial index, it's just basically a series of bounding boxes for the polygon that you have. So it doesn't give you exact locations, it gives you approximations within extents. So if we take our city data again and we load it in, we can build a quad tree index here. So we take our spatially enabled data frame and we do a spatial operation because we're working on a data set as a whole. So recall that the spatial works on a data set as a whole. Then we're going to create our S index, and we're going to specify the type, quad tree. You could also specify R tree as well, and that gives some additional capabilities, but they're unneeded in this point, and I wanted my index to generate really quickly. We're going to do an intersect, just doing by a minimum bounding box, and we're going to get out all the information. And here I'm selecting all the cities within the bounding box of New Jersey. But notice that there are cities that fall within actually the state of New York and Pennsylvania and some in Delaware because New Jersey isn't a perfect square. We could further dig into this by, now that we know our subset of data, we could use the geometry operations and look at disjoint to do that. I didn't show that here, but you can get the exact geometry of New Jersey and select out what you want, and then just display that area. Next, you can do advanced analysis, just using spatially enabled data frames in your in-memory data set. We can use geoprocessing tools, just like you would with a feature class in Pro. And we're going to do an example of creating a viewshed. So we're going to import create viewshed from ArcGIS, and I'm just going to select out 4 points. I'm then going to pass in my spatially enabled data frame to create viewshed and get back the results. So I'm going to look at the distance of 20 miles of what I can see from my viewshed. I'm then going to plot it on a map. So this was in South Charleston, West Virginia, and here's 1 point and the viewshed results. Notice what I did here is I took the results from the viewshed, which is a hosted feature service layer, and I was on top of that, I was also able to plot my in-memory points. So you can mix content in this case. This allows you to put both hosted feature service layers and spatially enabled data frames on the same map. You can even enrich spatially. You can even use geo-enrichment to gain more insights to the information that you have. So if we take our study area cities that we have, we can get data collection information for this example, the various ages within organization, within the area of interest for South Charleston. Notice when we do the enrichment, instead of getting back points, we actually get back geometry. We get back polygons. This is because when you do an enrichment, a point really doesn't have any value, and it does a default 1 mile buffer around any points that you provide. So it's just something to be aware of. And we can go back and plot it just using the spatial.plot. We can do custom analysis with spatially enabled data frame. So we're going to take a data set that I have, and this is Airbnb reviews. So this is a this is just a pandas data frame, and we look at it and we have lots of information. And we want to look at reviewing scores, and maybe we can use some nearest neighbor analysis to find associated points to each other. But before we do that, we can take advantages of pandas describe and get some basic statistics of what we're looking at. We can then select out all the records using simple querying and take advantage of pandas querying technique of any NA values and just take out anything that is NA or null. We can use the pd.dataframe spatial.fromxy and geo-enable our pandas data frame, and then display the area of interest we have. So we're going to get the full extent, pass it into our extent for our map, and we're looking over at Amsterdam. We can then take advantage of third-party libraries using spatially enabled data frames. I'm going to use scikit-learn and the cluster functions, pass it in, and we're going to classify on the rental price after doing some cleanup. We can do visualizations to determine the proper number of clusters that we can do, and using the elbow method we have here. So I'm going to choose 4 in this case, run my k-means, get back my classes, and then plot it back on the map. You can then do further analysis and look at the various metrics to see if that actual cluster amount was appropriate using scikit-learn as well. And you can display the clusters as well. So now we're going to hand it over to Young Yao, who's going to talk about visualizing raster data and doing some analysis. That'll be pretty interesting. Thank you.
Switch over.
What number?
Number 3. Yep. Cool. Thanks, Andrew. So let's get into visualizing raster data. So first of all, I'm going to talk about raster visualization basics, and then I'm going to talk about the raster functions that allow you to apply image processing algorithms on your raster data on the fly. So to begin with, this is just standard code. You import libraries and make a connection to your GIS, which can be the ArcGIS Online or your own enterprise system. And then let's search for imagery layer. In my case, I'm searching for multispectral landsat data, and I'm printing out the first 2 items. And let's say I decided to use the first item, multispectral landsat 8 data, which is the latest. And at this point, this is still item. We need to convert this item into an imagery layer. And if we run this cell, you will see the type of this variable is the imagery layer. And if we just query this variable by itself, you would get a screenshot for you to quickly get a look at how it looks. So in this case, I'm getting a landsat image at a global scale. So now we have the layer. Let's add it onto a map. So first of all, let's create a map with its center at Redlands, and then add this layer onto that map just by calling this add layer method. And it's there. So this is fully interactive. You can zoom in and zoom out, or just change the extent. The data will be added to those uncovered area. So this shows how easy it is for you to sort of visualize raster data. So now let's talk about raster functions. So raster functions might seem a little bit mysterious to you at the beginning, but they're essentially just image processing algorithms you like to apply to your raster data. It can be as simple as extracting a few bands, or you can do crazy stuff like deep learning with it. So, and there are two types of raster functions. The first type is the raster function that you published with your data. In other words, when you publish your data, you can choose to bundle a few algorithms with it. And let's see what this landsat layer has. So all you need to do is to call its properties and then raster function infos. And this would print out all of the raster functions associated with this layer. As you can see, we have one for agriculture, one for bathymetric, and one for color infrared, etc. So let's say I like to apply this color infrared raster function to my landsat layer. What can I do? So first, let's create a map. Let's call it infrared map. Oh, by the way, this color infrared raster function is a commonly used band combination to highlight vegetation. So all you need to do is just to import this apply method, pass in the layer and also the raster function name, and then add the result onto the layer. And now you get the results. And it's worth noting that at this point, this raster function is only applied to this screen extent, which means whenever you zoom out or change the extent of the map widget, this raster function will be applied to those uncovered area on the fly. So in that sense, it saves you a lot of unnecessary computation, and is super fast in that sense. The second type of raster functions is the built-in raster functions in Python API. For example, if you want to just create an NDVI image, you can just call this NDVI method directly. So let's first create an NDVI map, and then import this NDVI method. You pass in the layer and tell the function this is band 5 and band 4, and add layer onto the map. Now you get the results. Another way to compute things like NDVI is through map algebra by calling this band arithmetic function, which in my opinion is more flexible and allows you to perform more like user-defined map algebra. All you need to do is just to specify this formula. For example, this is the formula to compute NDVI. And you should get the same results with this code. So, and raster functions become more powerful if you can chain multiple of them together. For example, in the NDVI image here, it's still kind of hard to tell which area has the highest NDVI, right? So what we can do is just reclassify this map by calling this remap raster function. And what this function does is to reclassify pixels, whose values are above this threshold, 0.3 to 1, and then the rest to no data. And after this inner raster function, we can just call this color map raster function to display those high NDVI area with green color. So let's run this, create a map, and then add this layer onto your map. So those high NDVI area has become more visible and obvious. So when you chain multiple raster functions together, you can also choose to visualize the workflow using the draw graph method. It helps you verify and present your workflow. For example, here, I started with the original landsat image and then computed NDVI, used band arithmetic, and then did remap and then color map. So this, it becomes more helpful when you're performing more complicated analysis. So now you're done with your analysis. You can choose either to save your result as a local image by using this export image method and specifying the bounding box extent. Now you got local image like this. And also you can choose to export the result as an imagery layer as well, and then share it with your colleague or continue your analysis from there. And that's all I'd like to cover about raster, and I'll hand it back to Andrew.
Yeah, so you saw a lot of things that you can do, and we sort of wanted to show you a way that we could put this together. And then and then we're going to do some additional graphics and visualizations that you can do outside of maps. So the first thing I want to talk about in this past year, June 2018, there was a fire that occurred, and we wanted to do some analysis. And we wanted to create visualization products that we could get out and assess the burn damage that happened. So what we did is we took all these aspects that we talked about before, and we accessed remote sensing data. And we were able to use the Sentinel-2 layer, which comes with the Living Atlas, and was provided by the European Space Agency. So it gives you really fine, high detailed information that we can get from ArcGIS Online or even with your portal once you set up Living Atlas. We're able to select out our before and after rasters to do this. And what we did is we took our area of interest where the fire was occurring, and we filtered that Sentinel-2 data not only by a timestamp, but we also used our intersecting geometry. And we were able to see back the number of images that come back for that time. And we were able to select our pre and post imagery from that case. So we could start doing some visual assessment. First, we wanted to look at just the area when we got it. And you notice that you couldn't really see the burn scar that was occurring for this area. It's all smoky and hazy. So we took advantage of the various bands to improve our visibility of the burn area. We used bands 12, 11, and 4, and you're able to actually start to see the burn scars over the landscape for that time. Then, just to show a comparison, here's a before imagery to show that there's actually no burn scar in this area, so it's truly unique for that time zone, that time spot. Now we can go ahead and start doing some analysis. We can use what's called the normalized burn ratio and take the difference between the normalized burn ratio from the pre-fire, from the post-fire, and you get a value between 0 and 1, where 0 is low to no burn and 1 is very high burn. So now we're going to be able to extract and look at our information and either vectorize it or do further analysis, which we can derive informational products from. We're going to use band arithmetic and algebra that's leveraged from the raster functions that we saw before and calculate our delta. We can then go ahead and remap and recolor, and we get this nice workflow that you see. So you have your two Sentinel data, so your pre and post. We're going to do our band arithmetic and do some local remapping and color mapping functions. So you can not only visualize information, you can visualize workflows with raster data using the Python API. And it sort of has that look and feel, if you're familiar with Pro, of the model builder. At least I think it does. I don't know. If anybody disagrees, you can tell me afterwards. So we can go ahead and calculate areas, calculate the area using pixel math. So we know the size of the pixel, and so we know how much area that actually takes up, so we can figure out how much area we're burning. And at the time, we have over 3,500 acres burning at this time that have burned. We can then leverage matplotlib to display it as an informational product. So we can look at the low severity or no severity burns, and then out of the slice of pie, you can look at the high, moderate, and medium severity as well. We can visualize this information on a map. So this is an in-memory, occurring in real time once again, just raster data set of the burn scar. We can then convert it to, we can access our portal and convert it using raster analytics. So we can buffer it. We can buffer our burn areas. First, we're going to vectorize it, and then we're going to buffer it to get rid of some slivers that can occur when you convert raster data to vector data. And then we can go ahead and visualize that burn area once again on a map. Now that we have vector data, we can start doing impact assessment. So we can take this information that we have, and we can convert it to an in-memory, spatially enabled data frame. We can then intersect it and enrich it, and then we're going to create an age pyramid from that. So we're going to take those age statistics and try to identify the amount of vulnerable population with that area. So the enrichment creates this impacted area of people, and then we can pass that into our age pyramid function that we had before, and we derive an age pyramid that shows both male and female and the amount of population that exists with each of those groups within our burn area. And you can pass this information along to first responders so they know that we have so many, we have a high percentage of people between 70 and 74 that we need to make sure that we get out of this burn area if they're not out already, or we need to identify that they're there. So not only are we merging analysis, we're creating rich visualization by using third-party libraries. So I'm going to pass it over to Dave, who's going to show a little more examples of doing this.
You good? Yeah. Cool. Great. Thanks, Andrew. Just one other sort of thing to add into. So a lot of things that we've shown you have been spatially focused. You know, this is Esri, it's the, a GIS conference. So just to let you know that if you are doing some visualization and analysis, there are other third-party non-spatial libraries that you can use. So Andrew did a lot about the spatially enabled data frame. Spatially enabled data frame, as Andrew said, is a pandas data frame that has geometry accessors on it, so it's extended to contain that geometry information. You can also just read in normal pandas data frames. So here I'm reading in some government data on hurricanes, and I'm printing out all this data, and it's just a normal pandas data frame. So this can be very useful for opening a CSV, gaining some insight into it. You can also sort of kind of clean this data, look at it, so you can gain access into just one of the column names, in this case just the latitude merge names. You can, that actually returns a new data frame of just that column. You can also query this data frame. Let's say you knew this date was an exception in your data set and you wanted to get rid of it. You basically query it and you say, I want every single entry in this that is not this exact date. And then now if you notice of the IDs, it goes 0, 1, 2, 4. That was the third zero-based index entry that was removed. So just some different tips and tricks you can use with pandas to really clean your data. I know a common problem a lot of customers come to me with is they have a CSV, and when they read it in pandas, it's of type string, which doesn't inherently work. You need to convert it to type float. So you can do that, write it back out, and then you've cleaned your data, and now it'll display a lot better on a map. So just some other tips and tricks with pandas. Andrew has showed some plots. There are many good third-party external Python plotting libraries. Sort of the standard for a while was matplotlib. So just using a few lines of code, I can graph out a function line graph of a sine wave. I can configure the X label and the Y label, turn the grid on or off, and I can even save this to an external file. So you can view it in a Jupyter notebook, say if it looks good, and then write it to a file, and then even automate a workflow where you send that out to people in your organization. I've used something similar with this with my ArcGIS server for administration, where you create a bar graph of the different types of error code groups, save it as an image, and send it out to some team members if it meets a certain limit. Here's another matplotlib, just a bar graph with standard deviation built into it. So again, you can, the XY label, title, you can even specify a legend in this case, have a tight layout, make it look a little bit nicer, a little more condensed. There's also histograms, so you can configure, even have higher graphs, higher bars on it, be a different type of color. You can even normalize it. normalize the colors and stuff. So matplotlib is kind of been the one that's been around for the longest, and it does have a lot of those kind of basic ones. If you want to get into some really, really interesting type of graphs, I'll be honest, I only know of these in an academic sense, but you can make a facet grid using the seabourn library. Seabourn has a lot kind of more edge case type graphs, so this facet grid looks really cool to me. I'm not too sure of the use case of it, but it's out there if you want to use it. Scatter plots are a big one. So in Seabourn, you can make a scatter plot with a lot of points on it, with a legend. You can even do ranking on it. So definitely very powerful foregraphing on that. You can do a joint kernel density graph. That's kind of just a good way to kind of visualize data on two axes. And then a good old box and whisker plot if you're doing any sort of statistical analysis. So that is just kind of a nice little addendum of some tips and tricks. That's all the time that we have allocated for the presentation part of this. Again, please take our survey. But at this time, we wanted to leave you guys some time to ask us questions about various things. So thank you very much for your attention, and
thank you.
We'll yield the floor to you for questions.
Any questions? All right. Well, if there's no questions.
Was our presentation just that good that we answered everything?
It's close to dinner time.
All right, we got one. What's up?
When you're doing that projection, do you have ways of setting the transformation that you're using?
So it's done on the, there is an option for transformation. You have to know the individual, like the actual calls. There's no like helper like you would if you were to actually transform it in a geoprocessing tool. But yeah, you can do that.
Mm-hmm. Yeah, so, and correct me if I'm wrong on this, but the question was what type of user type to access notebooks. You should talk to the enterprise people, they'll give you a better answer on this, but the user role is now a creator, and then you need to be of type publisher. So version 10.7 added in the new user type, user role functionality, but it's, I believe, creator and then publisher for notebooks. But I think it depends on how you set up your portal. So the enterprise folks will have a better exact answer on that.
Any other questions?
Yep, over here.
So the spatial data frame, is that a similar kind of implementation of GeoPandas?
So the question is the spatially enabled data frame similar to GeoPandas? So GeoPandas uses inheritance to create there, so they overwrite default methods on pandas. They're both built on the pandas platform, but I didn't want to overwrite anything that pandas did. Pandas does what pandas does, and they do it well for a reason, and that's why people do it. So who am I to say to overwrite plot and other functions? So we took the preferred accessor pattern and we extended it out. We do similar things, but we do it in different ways.
Yeah, and just to talk on that, when you do have the accessor pattern, it does add for a lot more stability, because instead of us, the developers, managing a lot of this functionality you can do with, sort of data frame type things, Pandas manages all of it. So when you upgrade your Pandas, you're getting that upstream functionality a lot quicker than if you were to have done the inheritance model. So it just differs in the architecture from a computer science standpoint, and ours is better because Andrew wrote it.
Thank you.
Yeah.
Yes, sir. Okay, so the question is about publishing and not knowing what to do. What it really comes down to is how you're set up and what you need to do. If you're in a case, if you're doing, they both can do what you need to do, but if you have an enterprise setup, you can obviously use the Python API for ArcGIS. You can create SD files. So if you're in a situation where you have to publish to standalone servers, you're going to have to do either a hybrid method, depending on what version of ArcPy you're using, or you're going to have to use ArcPy solely to publish the standalone servers at this current time.
Yep.
Are there plans to move more ArcGIS functionality over to the Python API, like spatial ArcGIS?
So the question is there going to be more ArcPy functionality moved into ArcGIS API, the ArcGIS the API for Python? And what you're seeing, and you can see it with the hosted notebooks, is that these two products are becoming more compatible with each other as versions come out than one replacing the other.
Mm-hmm. Yeah, so I mean, the overall scope of ArcPy versus the Python API. I mean, the ArcPy has always been Python for your desktop. You know, when you're doing a lot of analysis, it's reaching into that underlying engine of ArcGIS Server or ArcGIS Pro to do that analysis, and then is, you know, spitting out the output. Whereas the Python API in general is sort of a shell around the REST API. So your analysis is actually happening on the server. And then of course all the spatially enabled data frame stuff Andrew has written does use the underlying you know, engines of Pro or Server. So I guess it is a way of what Andrew said of they are designed, and a lot of our samples in the hosted notebooks product do use both of them side by side. So, you know, it's not a matter of, you know, do you use a tool to replace a screwdriver? It's they both have their own purpose, and in an overall sample or overall notebook that you're writing, you can use them side by side, and, you know, the workflows really are they are intuitive, and they do come through, keeping them, you know, separate.
It's becoming more and more symbiotic. So
yeah,
like
symbiotic's a better word. Yeah.
I think that's a shorter way of saying what Dave said. Is there any other questions? Yes,
yep.
ma'am.
Yeah, there's so you can run Python. You can run the Python code that uses the ArcGIS API for Python outside of Jupyter Notebooks. Jupyter Notebooks are just great for visualization. The map widget works in Jupyter Notebooks, you know, graphing and stuff. But yeah, you can run just standalone Python scripts from a command line. You can integrate the Python, you know, API with other Python libraries, even through a GUI if you want. So yeah, the short answer is wherever you can run Python, you can use the API for Python. So the way the JavaScript widget works right now, that map widget that we used for this is it is only Jupyter specific at the moment. It's a Jupyter widget that integrates with the Python API. But what you can do is you can write some code that in a Jupyter notebook makes a map, and then you can export that map to a standalone HTML file and then send that off wherever. And then, you know, that can run outside of a Python context. But all of the map widget you see, it is Jupyter specific. That's the one exception of your question.
Great. Any other questions? Yes, sir. I'm sorry. Can you say that?
Can you say that again, please?
The question is, can you create a custom Jupyter widget, right? Yeah, if you follow the pattern that's set forth by, you know, the Jupyter project, and you follow their widget pattern, you can most definitely create your own widget. There's nothing to stop you. That'd be awesome.
Yeah, I wrote most of the widget for the Python API. So if you want to ask me questions afterward, I can help you to get started. But it's all documented. It's a very simple process, and it's very fun. I mean, I like it.
Any other questions? All right. Well, I guess I release you. Thank you.
Thanks, everyone.
And if you have any questions that you didn't feel like raising up and asking, we'll be around for a little bit. And then also, please stop by the Python Island if you think of anything as the day goes on, or tomorrow or Friday. We're here all week. And we really appreciate you coming. And we hope you come to the rest of the sessions that we have. Thank you.
Thanks.